Guys, so today we're going to be learning about the distributive property. So it's basically, some people might have recognized this by the term FOIL, right? So it's practically the same thing as FOIL, except that when you're FOILing, you tend to see the common FOIL example to be two binomials, right? So let's start with actually the common case of FOIL, right? X plus 3. Right, so this would be a good indication that FOIL is needed, right? So FOIL stands for first, outer, inner, and last, right? So first stands for the first two numbers will get multiplied. Outer means the first and the last one, because they're the outer parts of this whole thing. Then the inner parts are these two. Then the last ones are the last two parts of these two binomials, right? But no, binomial is this and this, right? So this times this, right? So let's do this step by step. First, it would be x times x, so that will give us x squared. X times 3, well, that's plus 3x. 5 times x is going to give us 5x. 5 times 3, this gives us 15, right? So now we have common terms right here. So 3x and 5x, they have an x and they're both to the first power, so that's a good indication that you can combine them. So what's 3x plus 5x? Right, it's 8x. And then plus 15. So a good FOIL problem right there. So let's do another one. Well, this time we won't do a FOIL one, it'll be a little different. Let's do x plus 5, and well, let's not get there yet. Let's do a negative this time, x minus 3, right? So minus 3 throw people off a little too. So what's x times x, right? Because it's the first, right? So this would be x squared, right? X times not 3, negative 3, right? This will give me minus 3x, right? X times this minus 3x. You always in every subject that I'm going to show you, you always keep the sign of the number in front. So if it's 3, don't just assume that it's going to be 3. Keep the sign in front, right? So x times minus 3, that's minus 3x, right? Now 5 times x, right? So it's going to be 5x, and positive 5 times negative 3. Well, this will give me negative 15. Right now I have minus 3x and 5x. They're both to the power of 1. So again, a good indication that you can combine them, right? So minus 3x plus 5x, well, that's going to give me 2x, right? So x squared plus 2x minus 15, right? So all of this, FOIL is generally categorized as a little part of the distributive property, but what it actually is anywhere where you have a parentheses and you have something outside of it, that's when the distributive property is used. So let's go on to the main examples. So what I mean is, let's say we have negative x and then parentheses x squared plus 3, right? This is the real distributive property in my opinion, because now you don't have these two parentheses things, but you have a variable outside the parentheses, and when you have a parentheses, the only way to get rid of it is using the distributive property. The distributive property just gets this whole thing and distributes it onto this. So it gets distributed everywhere. Well, what's negative x times x squared, right? So it's just going to be, assume it's just x, right? So x times x squared, well, that's just x cubed, right? But now we have a negative x, so it's negative x cubed. Now negative x plus 3, that's going to be minus 3x, right? So let's do another one with negatives, because I know negatives confuse people so much. So let's do negative times 5x plus x cubed. So in this case, maybe you might think, oh, I'm not going to use the distributive property. Well, no, because in front of these parentheses, there's a 1, right? So it's negative 1. This is a negative 1, right? Negative 1, and we have to distribute this negative 1 onto everything here. So negative 1 times 5 of x, well, negative times a positive, that's going to be negative 5 of x. Negative 1 times x cubed, that's minus x cubed, right? So we use the distributive property and we figured this out. All right, so let's do probably, let's do a little, probably the harder distributive property problem. So let's say this is actually like a two-step distributive property type of thing. So let's say we have x plus 5 and then we have x minus 3, right? So you would think that we can do these two using FOIL, right? Or distributive property, same thing. And get an answer and then just put a negative over our final answer. But in this case, I think it's smarter to distribute this negative sign onto this first. So let's distribute this negative onto here. We get minus x, right? And then this negative into the 5, we get minus 5. But we distributed this, but we have to put it in parentheses because this has become its own value, right? Because now you would leave it alone if there wasn't any other parentheses, because you have to be able to distinguish what's part of this this little part and what's part of this, right? So that's why we put the parentheses. And now we have x minus 3. So now minus x times x, well, that gives me minus x squared, right? Minus x times minus 3, that gives me plus 3x. Minus 5 times x, well, that gives me minus 5x, right? And minus 5 times minus 3, that gives me plus 15. Right here and here, we can simplify it, right? We have a 3x and we have a negative 5x. So if we have a 3 of x and a negative 5 of x and we combine them, that's like saying 3 minus 5, right? 3 minus 5 is negative 2, so minus x squared minus 2x, right? Because it's a negative 2 when you combine these two, so that's why there's a negative right here. And then plus 15, right? But it's not the only way to do it, right? So here's the result when we distributed it first. The negative sign, what you can actually do too is, if we have the same problem, x plus 5, x minus 3, since it's multiplication, doesn't really matter which order you go. It's just that if you distributed this, the reason I preferred this one over this one is because if you distribute this negative first, then it'll look like the common FOIL property problems that you've been seeing. It's something times something else, and then that something has two parts to it. It has a variable and it has a constant. So it really looks like a FOIL problem. Yet if we do it this way, it won't maybe look like a FOIL problem too much. So what we can actually do is we can distribute this. So assuming that that negative sign's not there, just distribute these, right? This onto here, this onto there, this onto this, and this onto this, right? So what's x times x? Well, that's x squared, right? X times minus 3 is minus 3x, right? 5 times x, well, that's plus 5x, right? And then plus 5 minus 3, when we multiply this, we get minus 15, right? So we distributed this, but we have to put a parentheses. Why? Because we have a negative, so we have to distinguish what's part of these and what's part of this, right? So that's why we put the negative. So now you have to distribute the negative sign, right? So if we distribute the negative onto this one, we get minus x squared. Minus times a minus 3x, that's plus 3x. So remember, there's a 1 here, right? So that's why I'm distributing. So now negative 1 times positive 5x, that gives me minus 5x. Minus 1 times minus 15, that's plus 15. So I have a 3x and a minus 5x. But if you guys notice, this is exactly the same thing as when we distributed the negative sign first. Look, minus x squared plus 3x minus 5x plus 15. Minus x squared plus 3x minus 5x plus 15. It's the same thing, which leads me to the conclusion that we'll get the same result. We get the same result. Alright, so that's it for distributive property.